Hey, welcome to episode 1 of Factorizing by Completing the Square. I'll take you through these notes. I am going to be annotating them with my finger on the screen. I hope it works out okay. If you missed it, here's a list of things we'd already gone through in class on how to complete the square. Great summary book stuff, great thing to refer to if you're still getting used to it. Do watch out for this one. The x squared has to be 1. If you start trying to complete the square without paying attention to coefficients of x squared, you are definitely going to have a bad time. We've got a total of 5 slides. This is the first one. If you want to pause and write this list down, go for your life. We'll keep going. I'm going to do 4 of these examples similar to the ones you'll see in the book. The question is here, what numbers have to go on the end of these quadratics if they're going to be perfect squares? The answer to the first one is 25. The trick there is take that middle number, halve it, you get -5, then square it, you get 25. Halve it. Oh, this writing's looking good, isn't it? Halve it, exclamation mark. Square it, exclamation mark. There we go. All right. Halve it and square it. That's our mantra for completing the square in perfect squares. If we know that we need a 25 in there, when we find one that isn't a 25, we can turn it into a perfect square. It's not what we're doing right now. We're just practicing coming up with the right number. So if that's a 7, we're going to halve it, would be 3.5, 7 over 2, and square it. Just halve it and square it. You could leave it like that, or you could write it like this: x squared plus 7x plus 49 over 4. 49 over 4, easy. You do that, try and ask someone on the street what 3.5 times 3.5 is. They'll be there for ages. 49 over 4, improper fractions, they're great. Even if it's negative, you still get a positive answer. Halve it, square it. Practice those in that question. Once you're good at coming up with what a perfect square should look like, then you're going to use it as a factorizing technique. Looking at this, x squared 8x plus 2, there's no factors of 2 that add to 8. So we've exhausted our techniques. Complete the square is going to be what we're going to do. Looking at the 8, half of 8 is 4 squared is 16. I'm going to put a 16 in there. Half x squared plus 8x plus 16. Take that 16 away and add the 2. And the reason I've chosen 16 because that is x plus 4 all squared there. And what have we got left over? Negative 16 and a 2 is minus 14. And the point I'm trying to make in class the other day, so this is like a perfect square, but it's 14 too small. It's a perfect square, but 14 less. This question is asking us to factorize, so we'll go ahead and do the difference of 2 squares here. Here's one thing squared, and here's, doesn't look like a square, but it's root 14 squared. So to factorize it, x plus 4 plus root 14, x plus 4 minus root 14. All right. Kind of run out of room, but we'll give it a shot. I'll try and be a bit neater. Pause if you need to get that stuff down. So once again, it's halve it and square it. So it's going to be 16 again. G squared minus 8 g's plus 16 minus 16 plus 5. So we've got g take 4 all squared is that much. And then we've got minus 16 plus 5 is minus 11. So we get g minus 4 plus root 11 g minus 4 minus root 11. And they should be written next to one another as a just like these ones were, but I've run out of space for other items on the screen. So that's those two. There are easier ones out there. When this third business comes in, don't wig out. It's just the square root of the first part plus the square root of the second part, square root of the first part minus the square root of the second part. Keep practicing. All right, I'll 2 to go. We'll notice that these have coefficients, so we take those out. 2 is x squared minus 3x minus 6, and we get a sinking feeling there's an odd number here, so we're going to have fractions. This is going to get ugly. Let's see. So leave the 2 out the front. It is x squared minus 3x. We've got to halve it and square it, plus 3 over 2 squared minus 3 over 2 squared minus 6. I'm just going to take up the whole screen here and actually not do D. We're already nearly 7 minutes in. I'll lose you otherwise. But I'll show you how to deal with these fractions. 2's out the front of all of this, so we've got the 2 out the front. We've created this bit on purpose, and we're probably at this stage wondering, what the hell is that perfect square? Well, how does this bit end up being 3 over 2 squared? That number's 3 over 2, of course. So we get x minus 3 over 2 squared. There's our perfect square. So we would no, I don't know how to find the laser pointer on this thing. That's okay. X squared is there. The 3 over 2 squared is there. And when you got a perfect square, you get 2 lots of them times each other. And so 2 3 over 2's is the 3. There it is. So what's this? You've got to have a common denominator. This number here, we'll do it in 2 steps, is 9 over 4. And this number here, if we're dealing in over 4s, in quarters, this will be take away 24 over 4. So we'll put that all together and then fully factorize. So it's x minus 3 on 2 all squared, 33 on 4, which is a pretty gross fraction. So we have 2 of x minus 3 on 2 plus root 33 on 4, should be on 4, and then x minus root 3 on 2 minus root 33 on 4, like that. That's okay. The square root, if we look at that third, 33 can be written as root 3 on root 4. And 4 can be square rooted, so it's root 33 over 2. And that will generally always happen, that denominator will come back out of the square root. So we've got 33, root 33 over 2, and this fraction is also over 2. So you'll often see it written, the answer in the back of the book, x minus 3 plus root 33 both over 2, and x minus 33 minus root 33, both over 2. If you write that out in neat writing, not using your finger, that'll look a hell of a lot better. But as you can see there, it's a dance routine. We follow the rules. We make our way to the end, and it always turns up an answer factorizing. Can you tell me what size that number is? If you had to draw the x-intercepts and get them in approximately the right spot. The square root of 33, well, the closest square root is 36. It's a bit less than that. So it's a bit less than 6. So 3 minus 6, well, not quite 6, will be minus 2 and a bit, and you halve it, it's minus 1 and a bit. So that number there and there is minus 1 and a bit. Is as close as you're ever going to have to know what that number represents. If you want to stop and go to your work now, great. I will go through this little exercise of where the axis of symmetry comes from. Actually, I'm just going to stop and put that in a different video.